Okay, something very interesting when I get to this time of the lecture and this part of the lecture, that's very interesting because we said each attribute has got a type of values, you know, number, text, a date, time, whatever, and has got a range of values that can be stored in it. You could have an attribute for which you have no value at the moment. Right? There's many things that could be like this. You know, you could have a staff that you just hired, but you haven't allocated this staff to any branch. So you enter the name, the staff number, the name of the staff, the address, the date of birth, sex, gender, salary, and then you get to the point that says enter the branch number, but you haven't allocated this staff to any branch. Right? So what do? So you store nothing for that attribute. Nothing is called null in a database. So when you have no value for an attribute, it's called a null value. I shouldn't say null value. Its value is null, but it's basically nothing. I know when I say there's no value, then I say null value, and it's a bit of contradiction. The same way, you know, many times you see your friends say, let's go for a coffee. You know, my friends are like this in this university, and say, it's fine. When we go and order coffee, so how much money you got? So I've got $0. So I said, okay, thanks God, I have got few dollars. In mathematics, you've got 0. In database, you've got null. And these two are very important. 0 in math and null in a database. Imagine if you didn't have 0 in mathematics. Life would be very difficult without 0. One of the most important numbers is 0. Many of us try to avoid 0, you know. We don't like 0 in many cases, you know, $0. Some of the things are good. 0 fines maybe is good, you know. But the same thing, when you have no value in mathematics, 0 is a value, I shouldn't say that. When you want to represent nothing, we say in mathematics 0. When we want to represent nothing in database, we say null. So when you don't store anything for an attribute, it has got automatically a null value. And that's very important. Imagine if I go with my friend to the coffee shop and say, how much money you've got, and there is no 0. There was no 0 in existence. So what would he say? I would say, I've got nothing. Yeah, that's right. So, and that doesn't help us, you know, in your calculation. When you have got null, you can check that if a data item has got a value or doesn't have a value. And how do you check it? You check if its value is null. So when it is null, that means it doesn't have any value, in a sense. So again, null is not a 0, is not a space, is nothing, right? So 0 is not null. A space is not null. Nothing is null. Okay, so null represents nothing. All right, let's move on. Just a few bits and pieces, and then we start with the really sweet part of the database and the design and etc. I know it's just becoming a bit difficult with so many terms and etc. But now that we said primary keys are unique for each row of a table, right? Each student has got a unique student number, right? So a primary key cannot be null, because null represents nothing. And many people may have a null value in one of their attributes, or in certain attributes. So a primary key cannot be null, right? The primary key cannot be null, because null doesn't uniquely identify something, right? There's nothing. So, and that's what's called entity integrity. Entity integrity tells you primary key cannot be null. Referential integrity refers to relationships between entities, and it says a foreign key value in a table should match a primary key in another table, because the foreign key is an attribute that's the primary key of another table. So if you have got a value as a primary key for that attribute in this table, the foreign key in the other table will have uniquely the same value. So if you've got branch 003, and the person works in branch 003, so you will have that in the table of staff. Right? So a foreign key either will have has a unique value or can be null, right? Because if it doesn't refer to any value in the other table, then it should be null. So the foreign key values should match a primary key in another table. And that's what's called referential integrity. You will learn about it more. I'll put in a couple of questions in the tutorial. You'll learn more about it. Now you know the entity integrity. Primary key cannot be null. Foreign keys, if it has got a value, should match a value in the other table, or it should be null. Then you can also set for each of your attributes certain constraints, and these are called general constraints that you can set to each attribute. For example, if you store the number of books a person borrows from a library, you can say, the number of books that the person can borrow cannot be more than 10. So a person can borrow only 10 books. So you can put that constraint on the top of the other constraints that you learned, the entity integrity and referential integrity. So you can set conditions on each attribute and the values that they could have. How are we going with the time? Domain represents a set of values, but you can set certain conditions, you know what I mean? For example, if you store in gender or sex of a person, you store staff and you store gender, and you say gender, the condition is just one letter, one character, it has to be F or M. When you say it has to be F or M, then you just put extra condition. When you say it's one character, it could be any of the letters, any of the numbers. But when you say it's only either F or M, then that's what you accept. So if somebody comes to your organization, has to choose one of those, either F or M. You don't accept anything else. Yeah? So views we talked about. Views are the interfaces to the database that you build for each customer, on different customers, different views. So student views are different than the staff views, and the staff views could be 3 different staff views: academic staff, administrative staff, other staff. So you've got the interfaces that are built for you, that you see your data from the database, and that's called the view. Where the data comes for the views, the data comes from a table or tables. It could come from one or more tables. So when you look at your enrollment details, you see your information that comes from the table student, and you see subject information that comes from the subject table, and then enrollment dates, etc., that relate to the enrollment, which is in another table in your database. So when you look at the interface or the views, you don't see where the data comes from which table. And that's the beauty of the views, because you don't want to know about this as a user. Just tell me which subjects I'm enrolled in. But the data could be coming from many tables. And the data that comes from many tables could be the primary key data, could be foreign keys, could be other attributes. So views bring the data from the database. So if your address is changed in the database, as soon as you log in again and you look for your information, you will see new address, and that's what it says: dynamic results of one or more relational operations. So it's the data that you get on your screen, on your interface to the database, which we call a view, comes from several tables. Okay, and we might just do lots of operations to get that data out, and we'll talk about these operations later on. The data that you see on your user interface just comes from the database. If the data in the database is changed, the data straight away is updated on your views also. So in reality, there's nothing in the view. It just comes everything from the database. Why we use views? Because we don't want to give you access to the tables in the database. Because we don't want to train you to be the database designers and users to be able to use to access your data. And it's just confusion. So we close the database, we keep it secure, and then we just send the data that we think each user needs to each interface. So when you log in, from your login name and password, we figure out you're a student and bring the student data up. And we have some buttons on this screen that you can press, say my enrollment information, and then we just execute another operation or command or query to the database and bring that from other tables or multiple tables and show it on your screen. You wouldn't know where it is, which table, which database. You don't have no idea where the data comes from, but they're stored in tables. So that's the beauty of it. So it just is also a security measure so that the person doesn't have access straight to the database. So, and doesn't know where the data is, how we stored it, what type of data it is. So it just gives a bit of more security and privacy to the database.